Hi students, here's a review for Spiral 3. We're going to start off with 2 sections that are graded, and you got to do some linear functions and factoring, and then some domain and range, etc. To start off, we got to write an equation for line K through 2 points. At this point, I hope that we know that we need to find a slope, and that's going to be something like 1 minus a over b plus 3. And hopefully we're going to use point slope form because it's a little bit easier for us to work with. You could either start with b comma 1, as I'm going to do, and do 1 plus 1 minus a over b plus 3 times the quantity x minus b, totally fine. Or if you prefer, you could use the other point, negative 3 comma a, and that would end up with something like y equals a plus 1 minus a over b plus 3 times x plus 3. Either way, I've got to choose one of these in order to find the x-intercept. I'm going to choose the first one because that's what I wrote first. And x-intercept means that y is equal to 0. So we get 0 is equal to 1 plus 1 minus a over b plus 3 times the quantity x minus b. In order to get x by itself, first thing I'm going to do is to minus 1 to both sides, so that becomes minus 1. And then I'm going to multiply by the reciprocal of my slope, so b plus 3 over 1 minus a on both sides. b plus 3 over 1 minus a. And when I do that, I'm just left with negative 1 times b plus 3 over 1 minus a. And on the right side, those pieces cancel out, leaving me with x minus b. To get x by itself, I'm going to add b to both sides, and I could write this as something like b minus b plus 3 over 1 minus a is equal to x. And that would be totally fine. There are a number of other ways that I could write this. The trick that I'd like you to pay attention to is that I did not multiply stuff out. I did not try to simplify. I left things factored and a little bit unpleasant because that makes this easier to work with. For another apparently number 1, we're going to be solving the quadratic by factoring. Here we've got 0 is equal to 6x squared minus 11x minus 7. And I'm going to start by multiplying those two terms together. So a times c is going to be negative 42. And I'm looking for things that add up to negative 11. So I'm going to multiply to negative 42 and add up to negative 11. As soon as I see negative 42, I want to do like negative 6 times 7, but those don't add up to negative 11. Okay, maybe I'll do double 7 and half 6, and I get negative 3 and 14. That's close. I got positive 11. Let's make those opposite. All that does is give me what I need to do to break this middle term up. So we get 0 is equal to 6x squared plus 3x minus 14x and minus 7. I can take a 3x out of my first 2. I'm left with x plus 2x plus 1. And I can take a minus 7 out of my second 2. And I'm left with 2x plus 1. That leaves me with 0 is equal to 2x plus 1 times 3x minus 7. That means that 2x plus 1 is equal to 0. In other words, x equals negative a half. And 3x minus 7 is equal to 0, which means that x is equal to 7 over 3. For number 2, this is quadratic-like because we've got 4 and then 2 for powers. And this one factors pretty quickly into x squared plus 2 times x squared plus 2. Okay, both of these are the same. So if we get x squared plus 2 is equal to 0, that means that x is equal to plus or minus the square root of negative 2. Not something we're going to use in this course, but you should know that the square root of a negative number is what we call an imaginary number, and we could write this as the square root of 2i. There are no real solutions to that problem. For the domain and range stuff, I've got to find the domain of j of x algebraically. Okay, that has two issues. Issue number 1 is that we have a fraction. So 2 minus the square root of x cannot equal 0. If I add square root of x to both sides, we get that 2 cannot equal the square root of x, and specifically that x cannot equal 4. The second issue is that we have a square root going on, and that means that the radicand, the stuff inside the square root, has to be greater than or equal to 0. When I combine these two statements, so x has to be greater than or equal to 0, but x cannot equal 4, that's totally fine. In intervals, this would be the interval from 0 to 4, non-inclusive on the 4 side, in union with the interval from 4 to infinity. The domain and range of n of x. Okay, well, the domain, I've got to take a look at every point for the x values. It looks like we're going from negative 5, not skipping any points, to 5. Oh, I'm skipping a point here at 4. So this would be from negative 5. This is okay because I filled that one in down below. I filled this one in up above. So we go from negative 5 to 4. We're going to stop there, and then union from 4 to 5. Anything else that you write that means all the values from negative 5 to 5, but skipping 4 is okay as well. And then the range, this was the domain. The range of this, I look for the lowest point. That's going to be 0. I look for the highest point. That's going to be 3. And even though I have holes there, I've got points that are at other places in there, so there are not any vertical holes. The range is just from 0 to 3. Next up, we got some exponential and log stuff. For number 1, which is designed to be done without a calculator, I've got to evaluate this log. One way to think about this is using what we know about logs, which is that if a base to an exponent is equal to some argument, that means that log of that base of that argument is equal to that exponent. Here we have the second form here. So this is looking at 5 to some exponent is equal to 625. That exponent is going to be 4. That means that log base 5 of 625 is 4. For the second one, which is labeled with a dot instead of a number, okay, we're going to expand this using properties of logs. The first thing we do is to expand all 4 pieces of this, although if I do x to the 5th over x squared, I can reduce that to be x to the 3rd, and that might be a little bit easier. So I might write this as log of x to the 3rd plus log of y to the 4th minus log of z to the 4th. If you hadn't done that reducing at the beginning, you would have had minus x squared, and this guy here would have been x to the 5th. It would have come out at the end. Next, I'm going to deal with the exponents, and all 3 exponents are going to come down front. So we get 3 log x plus 4 log y minus 4 log z. For the third problem on this page, we got to solve an exponential using some kind of a log to solve it. And to do that, we're going to minus 3 to both sides. We get 5 to the 2x is equal to 7. use log base 5 of 7 is equal to 2x, and then if I divide by 2 to both sides, we get x is equal to log base 5 of 7 over 2. That's the exact answer. The approximate answer, which if this is a non-calculator spiral, I don't remember if it is or not, you don't have to do. You got to do log base 5 of 7 over 2, and you should get a value of 0.6045. Thousandths would be up to there, so 0.604 or 0.605 would be acceptable. On your calculator, you can either use log base or you can convert between logs, depending on the calculator that you have. I'm happy to show you that individually. And then finally, we got one more log problem, which is going backwards from what we just did. So here we've got a log expression. I'm going to convert this to exponential first. 3 to the 4 is equal to 2x plus 3. 3 to the 4 is 81, is equal to 2x plus 3. If I minus 3 to both sides, we get 78 is equal to 2x, and that means that 39 is equal to x. Sometimes logs go wrong. It's a good idea to check by plugging this in. 2 times 39 is 78, plus 3, we get 81. Log base 3 of 81 is indeed 4. Next up, we got working with functions. This is another feedback-only section. And we've got f of x is equal to 3x, g of x is equal to x cubed plus 1, f of g of 3. First thing I'm going to do is find g of 3, which is 3 cubed plus 1, happens to be 28. F of 28 is going to be 3 times 28 minus 1. 3 times 28 is going to be 84, minus 1 is 83. For number 2 on this page, the numbers seem to be very arbitrary this time. J of n of 0. So first off, I'm going to find n of 0. N is the graph. N of 0 is 2. So j of 2 is going to be 1 over 2 minus the square root of 2, and that's it. Second one, we've got n of 0. We found n of 0 already, so n of 0 is 2. Then we're going to find n of 2. N of 2 has a filled-in circle at a height of 1, is equal to 1. Third one, we're going to find n of j of 1/4. So first off, I'm going to find j of a 4th, which when I plug that in, we get 1 over 2 minus the square root of a 4th. Square root of a 4th is a half, so 2 minus a half is 3 over 2. 1 over 3 over 2 is going to be the same thing as 2 over 3. All right, so now we've got to find n of 2/3, or as best as we can, because that was not what I intended for this problem, but that's okay. So we're somewhere up there, and there's no way for you to know what the equation of that is offhand. So I'm going to say that's a little bit less than 3, maybe 2.8-ish, being the formal way to describe that. All right, and finally, n of j of 4. So I got to find j of 4. J of 4 is going to be 1 over 2 minus the square root of 4, which is going to be 1 over 2 minus 2, which is 1 over 0. I cannot plug that in. This does not exist. J of 4 is undefined, therefore I cannot plug that into n in order to get that value. Finally, we've got some limit stuff. I'm going to zoom in on these so we can get an understanding of what's going on here. The limit as x approaches -4 from the right. Okay, I'm going to start at -4 and then go to the right of this, and I'm looking at what is this approaching. That's approaching -infinity. You could also say decreases without bound. The limit as x approaches -4 from the left. Same point. Other side. This time we're approaching positive infinity. We could say this is increasing without bound. As x approaches infinity, okay, what's happening to my graph as x is going to the right? We appear to be approaching a value of 5. That's a horizontal asymptote. And finally, as x approaches -infinity, as we go to the left, my graph is approaching a height of 5 as well. Okay. For the second problem on this page, we're taking a look at this weird limit graph, and we've got to decide which of these statements is false. First thing I'm going to do is underline false, because that's something that we need to be really careful with. Often when we ask questions that are multiple choice, we have a tendency to look for answers that are true instead of ones that are false. So when you're asked to find something false, it can cause some problems for us. The limit as x approaches 2 exists. Okay, for I know for a limit to exist, the limit as x approaches 2 from the left of f of x must equal the limit as x approaches 2 from the right of f of x. So taking a look at 2, as I come from the left and as I come from the right, both of these are approaching a height of 2. This one's okay. And because we're looking for the false statement, this one does not work. The limit as x approaches 3 exists. Again, that means the limit from the left and the limit from the right have to be the same value. So as I come to 3 from the left, from the right, we are approaching the same value of 5. This one exists and it equals 5. The other one would have equaled 2, just so I can put those there for no reason. This one exists as a limit, therefore it does not work for our problem. The limit as x approaches 4. Okay, I know the limit from the left is going to be 2. The limit from the right is going to be 4. Okay. This one does not exist because the limits from each side are different. The limit as x approaches 4 from the left of f of x is 2. The limit as x approaches 4 from the right of f of x is 4. Because those are different, that limit does not exist. That's going to be our answer. But just to kind of keep going, the limit as x approaches 5 from both sides. Okay, I approach the same value, in fact the same point. That's equal to 6. And the function is continuous at x equals, ooh, that's fun. You guys can't see that either. Let's go with x equals 3, because we already found the answer. And therefore, this one can't be that. And at x equals 3, the limit on both sides clearly is the same, and if you can kind of make some sense of what's going on there, that's pretty clearly continuous based on what we know about continuity so far. That's it.